3D-принтинг на місяці. Вітайте! Я перепрошую, одне уточнення. Ми хочемо, щоб наше відео з паном Сергієм попало на, якщо ви знаєте, TED Global, тобто це сайт, де збирається найкращі виступи в всьому світі. Це для нас є тільки можливим, якщо пан Сергій виступить англійською мовою. І паралельно, як ми повідомляли, ви на телефоні можете включити FM-станцію 95.0, включивши навушник, і ви зможете онлайн отримати переклад виступу, який буде виступати англійською мовою. Ми ставимо перед собою надзвичайно амбітну ціль, як рух TED, для того, щоб виступ з українського TED попав на глобальний інтернет. Тому, будь ласка, виступ англійською мовою, переклад на навушниках на станції 95.0. Дякую.
When the first astronauts, when they climbed into the lunar module, after they completed their lunar walk, they brought along with them lunar regolith into the lander. By the time they removed their helmets and their gloves, they could feel, smell, and even taste the moon. The characteristics of this regolith is so granular and abrasive that despite them trying to clean their suits off before they climbed into the lander, they still managed to trump the stuff back into the module. They even got under the tips of their fingernails. This type of contamination obviously brought some great worry. This potentially could have harmed or even killed them. But it wasn't until they went up there that they realized what they were up against. Just to put it in perspective, the type of granularity that we're talking about, a sample taken from an Apollo 17 spacesuit showed that per 1 centimeter square, 250,000 lunar particles could be found. This sample was taken after the astronauts scrubbed their spacesuit and climbed into the lander and contaminated it. This sample was taken after the engineers vacuumed and cleaned the suit. Lunar regolith has been reduced to a small size conveniently through meteoric impacts and continuous bombardment of charged interstellar atomic particles. This is the type of And this process happened over 1 billion years. This is the type of stuff that we want to use, this is the material that we want to use for 3D printing on the lunar surface. Samples taken from Apollo sites and Lunar missions took this dust, this soil, this regolith, and in some cases, 18% of titanium could be found per sample. If we were to visit these heritage sites, we would see elements such as calcium, aluminum, silicon, iron, magnesium, and titanium, all in the form of oxides. So before we actually start printing with it, we have to have a chemical reduction to get those elements into its pure state so that we can either use it for propellant or for a 3D print. This next picture, when I put it together, I was like, hey, it looks like a piece of pizza, but it is not a piece of pizza. What I want you to see here is the next time you look at the moon, picture that a quarter of it is actually oxygen. The difficult part is how do you extract that oxygen from those materials? This whole 3D printing business on the lunar surface has been central to us since 2012. And us is, we are Team Plan B of the Google Lunar X Prize. we are the only Canadian team in the international competition. Here are some of our members. Both are Alex's. Our lead is on the right. I had to stretch this picture a little bit so they look a little wider, but the guy on the right is actually, he's always been chubby, but one's a mathematician, the other one is a physicist, and together they bicker and fight and argue and come up with some good solutions. The Google Lunar X Prize itself, at a high level, it's an international competition where you have to deliver a payload in the form of a rover or a hopper, and have that rover or hopper travel 500 meters and stream high-definition video or images back to Earth. I met with some of these members, and there's some good talent in the Google Lunar X Prize. And there are teams that are looking to use their rovers to find lunar caves for potential future bases. There's another team that is investigating how could we mine resources from meteoric impacts and bring those resources back to Earth. Another team that shares a similar interest with us is looking to build a 3D printing module that will serve as a proof of concept that 3D printing is possible using lunar regolith on the lunar surface. But why would we ever want to 3D print pieces on the moon? Well, it turns out that launching a satellite to geosynchronous or geostationary orbit is far more cost-effective launching it from the moon than it is from Earth. The moon could also serve as a stepping stone for missions to Mars, as well as a fuel depot once we can extract that oxygen, find that hydrogen, and get it to come. Imagine that one day we can 3D print a 3D printer. And then that new printer would print other applications like camera, metallurgy, communication devices. Imagine that one day in the future we'll be able to remotely use lunar regolith to print essential processing unit, like the IBM S360, which can be printed today. It'll be just ginormous. But before I keep on throwing you into fairy tale, the reality is that 3D printing is said to not be achievable by my generation. This is said by a number of experts. 3D printing on the lunar surface, that is real. And does that mean we quit our jobs? If we take a look at some of the technical challenges that are involved with 3D printing on the lunar surface, the actual print itself can be done using a number of methods. The method that we're going with is to use spark plasma sintering. The actual difficulty lies in harvesting and processing that dust, that soil, before any print is made. Depending on where we land, we're exposed to different minerals, lunar minerals. So we would have to break those minerals up and eventually reduce those elements from their oxidized state for our print. So the first thing our first task is we want to find similar sized particles that we want to work with, these elements that we want to work with. And one method of achieving that is if we were to take a plot of soil and statically charge it. And I believe this to be a bit of a romantic technique, but the lighter particles will float higher than the rest, and the system will grab that top layer. Once that is completed, we're faced with filtering those elements, because we don't know which we want to separate them before we do a chemical reduction. And some lunar minerals contain iron, some don't. So whatever filtering processing technique you're using, at the end of it all, we'll still probably be left with 40% of the materials that we actually want to work with. So we have to run that filtering process one at a time. Eventually, we'll get to a point where we have the right grains and the minerals that we can work with. Now we're faced with the task of chemically reducing those compounds from their oxidized state. Just to give an example, if we were to take one technique, if we were to take pure aluminum, and if we were to use aluminothermic reaction, we can reduce iron oxide, causing that pure aluminum to be oxidized again, and we have to reduce that aluminum one more time. The beautiful part is that there are already many patents and experiments that were done decades ago that deal with extracting that oxygen and reducing those compounds into their pure state. This was done a long time ago. I hope now the audience can begin to see the type of difficulties that are involved with 3D printing on a lunar surface. And this is why our team takes a bit of criticism when we talk about that subject, because finding a way how to launch a payload to the moon at an economic price is challenging enough. Why go to the moon and not start laying a foundation? Some of the reducing agents that are used in the chemical reduction are hydrogen, chlorine, and carbon. Carbon is not one of the elements that is found, that was brought back in the samples from the heritage sites. This guy here, this is our rover. This is our close to 4 years now. This is our model, so it has changed, but it is made out of carbon fiber. And carbon is good for reducing such oxidized elements such as aluminum oxide and iron oxide. If done correctly, once this rover has served its purpose, we can recycle it for future chemical reduction. And if it's done properly, we can keep on using that carbon, so it's not a one-off. So this is one method, one example of laying a foundation for future metallurgy or 3D printing on the lunar surface. Our team likes to add a complex layer to already a complex project. But if we don't ask the tough questions, things would be just a bit boring if we don't try to achieve the impossible. If our team doesn't even come close to the moon, but adds a drop of knowledge to that bucket, I'll be happy. The interesting part is this talk is taking place in Ukraine, home to Yuzhny and Dnipropetrovsk. We were there last summer, and we got to see the amazing halls with these rockets being assembled and their payloads being prepped. There are experts there that carry a wealth of knowledge that should be standing here in my stead. Use their talents. Lastly, if your idea is earthly or space-bound, to the audience I'd like to say, I hope we all have the courage to push our ideas, even if our ideas may seem as ridiculous as 3D printing on a lunar surface using lunar regulator. Thank you very much for your time.